All right, today we're going to talk about one of the most powerful tools in all of algebra. Think of it like a master key for solving a certain kind of equation that, believe me, you see all over the place. Let's jump right in. You've totally been there, right? You're staring at an equation, a quadratic one, and it won't factor. It's like you've hit a total brick wall. Super frustrating.
You know, some equations are pretty friendly. You look at something like x squared plus 7x plus 10 equals 0, and you can see pretty quick, oh yeah, that's just x plus 5 times x plus 2, done. But then you get slammed with something like this other one, x squared plus 10x plus 2 equals 0. Go ahead, try it. You're just not going to find two whole numbers that multiply to 2 and add up to 10. So now what?
What if I told you there's a master key for this? A single, totally reliable method that can crack not just the tricky ones, but literally every single quadratic equation you'll ever meet.
And here it is in all its glory, the quadratic formula. Now I know, it looks a little intimidating at first glance, but trust me, this thing is your absolute best friend for any equation that's in that standard ax squared plus bx plus c equals 0 format. And the best part, it never fails. It works every single time.
So talk is cheap, right? Let's actually put this formula into practice. We're going to use it to finally solve that unfactorable problem we were stuck on a minute ago. Okay, step one couldn't be easier. We just have to look at our equation and pull out the numbers for a, b, and c. Remember, there's kind of this invisible 1 in front of the x squared, so our a is 1. The number chilling with the x is b, so that's 10, and the constant, the number all by itself, that's c, which is 2. Easy enough. Now for the plug-and-chug part. We just take those three numbers, 1, 10, and 2, and carefully slot them into the right places in the formula. So b becomes 10, a becomes 1, and c becomes 2. The only thing you got to do here is just be careful. Double-check you put everything in the right spot.
And now we just do the math. Just follow the order of operations. So 10 squared is 100. Then 4 times 1 times 2 is 8. So under the square root, we've got 100 minus 8, which is 92. Now the square root of 92, we can simplify that. We look for perfect squares that divide into it, like 4. So the square root of 92 is the same as the square root of 4 times 23, which becomes 2 times the square root of 23. After one last little simplification step, we get our two answers. X equals -5 plus or minus the square root of 23.
And boom, there it is. A nice, clean solution to a problem that looked completely impossible just a few minutes ago. See, that's the real power of this formula.
But wait, because solving the equation is actually only half the story. Tucked away inside this formula, there's this secret feature. It's kind of like a mathematical crystal ball that can tell you about the answer before you even do all the work. I mean, just imagine knowing right from the start if you're going to get two real answers, or maybe just one, or even these weird complex answers. Well, turns out you can. I'd like you to meet the discriminant. It's this little piece of the formula right here, the parts living inside the square root, b squared minus 4ac. This small expression right here, it holds all the predictive power.
Seriously, the number you get from calculating just this one little piece tells you exactly what kind of answers you should expect to find at the end.
And the rules are super simple. If the discriminant turns out to be a positive number, you're going to get two different real solutions. If it's exactly 0, you'll find there's just one real solution. And if it's a negative number, well, that's your clue that you're about to get two complex solutions. You know, the ones that involve the imaginary number I.
Let's see this in action. It's pretty cool. For our original problem, the discriminant was 92. That's positive, right? And just like it predicted, we found two real solutions. Now, look at a different equation, like 2x squared minus x plus 2 equals 0. If you calculate its discriminant, you get -15. So, because that's negative, we know right away, without doing any more work, that we should expect two complex solutions. It's a fantastic shortcut.
Okay, so let's tie this all together. Why is this formula more than just a cool math trick? Why does it really earn the name of an algebraic super tool?
Well, as our source material says so well, it's not just about getting the answer. It's about understanding the nature of the answer. That discriminant gives you a deeper insight before you even finish the problem. So, here's the bottom line. The quadratic formula is your universal key. It gives you a rock-solid step-by-step method for any quadratic equation.
no exceptions, and its built-in crystal ball, the discriminant, lets you predict your results. That makes it an absolutely essential tool, not just in algebra class, but way beyond, in fields like physics, engineering, even economics.
So now you have this super tool in your back pocket. You're ready to take on any quadratic equation that comes your way with total confidence. The only question left is, what problems are you gonna unlock now?